Welcome again. Today we are going to learn about session state in Streamlit. I have seen countless developers, even experienced ones. They struggle with this session state. They get confused. They write buggy code and they give up. Why? Because of a common belief. They think session state is just another Python variable. It's not. Because here is the truth. The That mental model which says session state is a Python variable is wrong. Streamlit behaves differently than standard Python. It's a framework. And if you don't understand the life cycle, your app will always have amnesia. It will constantly forget your users' hard work. And today we are going to fix your mental model. We are going to take you from confused to an architect. Because session state is not confusing, it's misunderstood. And we won't just learn the syntax, we are going to apply this by building a project that follows strict industry standards. We will use separation of concern, the dry principle, and solid architecture. We'll do all those things on a small scale, but still you will get understanding on those concepts as well. And let's check out the project which we are going to do, which you will build in the end of this session. So today you're going to build this Pro Tasker app. It's a simple task management app. You add tasks from here, you set priorities from here, and then click on this button and the task is added through session state. Now how to control app memory, how to manage state across reruns, how to make your data persist. This is what makes this different. You will also see how real teams structure their code. How do people in industry break things into modules, which I am sure a lot of you are already aware. We'll follow all those practices like keeping UI separate from logic, write code once, use it everywhere, all those things. So, okay. So let's do this. All right. So most of you who have been watching our videos, you understand we watched this model watch, code and build. Watch is where we first discuss on mental models. Code is where you will code along with me, and a build is the final state where you build the entire project so that you have something tangible in your hand. So we'll follow the same methodology in this lecture as well. So let's start into session state and let's look at this code. Very simple code. This code has a problem. This code looks simple. It looks simple, but this code has a problem. Count is 0. We start with count is 0. If we click, we add 1. We are adding 1 here. When we try it, we click this button. Then we get 1 again. You still get 1. You click it multiple times. The count is not changing. It never changes. And let's try it. Let's try this. Let's come to my screen. Can you see my screen? Okay, awesome. So I'm going to open. So first of all, have you downloaded this code repository? For this entire course, we are on chapter 4 right now. Right? You can download it from here, and I have already, let me do git fetch and let's say git status. Okay, up to date. Perfect. So I'm going to start my favorite editor, VS Code. And chapter 4, we'll go to starter. So starter is where we will do practice, and final is the final code which you will get in your final folder. So let's start with practice 01. So first let's do a simple let's rerun this code. Count is equal to 0. Count is equal to 0. Let me click on command B to hide away my file browser. Count is equal to 0, sorry. And if we click if st dot button, let's put a label, increase count. Okay, then what we want is the count should add a +1 value, right? Increase count by +1. Perfect. And let's write this st dot write count. Simple code, nothing fancy. Let's run this. Okay, increase count plus 1, count is 1. I keep on clicking this button, as you can see, but the count is not increasing. Why? Because whenever you click on a widget, this Streamlit refreshes your entire page, and the count is again initialized with the value of 0. Count is again initialized with the value of 0, and then with this click on this button, the value become 1. But that is not what we are expecting. We want this count should not have amnesia, but my count variable is having an amnesia thanks to Streamlit. How do we solve this? We solve this using Streamlit session state. Okay, so come back to this smart board, whatever. So why this happen? Here is why. Remember our architecture, top to bottom. Every time you click that button, the entire script reruns. It starts at the line 1. It sets count back to 0, which we discussed. It doesn't care about the past. It wipes the slate clean. And that is why your data dies. Because your script is rerunning. Whenever user clicks the button, actually, a script runs from here. Yes. So whenever somebody clicks the button, the script reruns from here. Are you getting me? Not here. So this was wrong, but script as soon as somebody clicks that button, because widget interaction demands a rerun, and that's the reason your count is 0. Perfect. Now what is the solution? The solution is session state. Think of your normal variables like a goldfish. Why goldfish? Because they have very short memory, or they have no memory. But session state is like a safe. Session state is like a safe. It lives outside the rerun cycle. When the script restarts, it doesn't reset. It's because it's saving everything. It reaches into the safe of session state and pulls out the saved data. It allows variables to survive. It allows your app to remember, and that is the power of session state. Now, I know we are just going fast in terms of theory, but let's go into theory once, and then we'll come back to code. But before, let me open the book. Just give me 1 second. Okay, perfect. So I have downloaded the book. Can you see the book on my screen? So this is the book. The book is completely free. This is a course book. We follow this book in all our videos. You can get the link in the description. Anyways, let's go to a chapter 4. Okay, this is chapter 4. Yep. Yes. So we have discussed the rerun problem. Yeah, we have discussed that. Awesome. And okay, session state dictionary. Okay, session state is an object. It behaves like a dictionary. Session state is a Streamlit object, but it behaves like a dictionary. So this means it has different keys. We'll learn how to use those keys. But first, let me see. Common dictionary method. Okay. So let's do one thing. Let's run this code. Where is my screen? Okay. So we have done this. Let me comment this out and run a simple count in session state this time, right? So since, as I said, like Streamlit session state, we are talking about a session state. So what so session state is a variable which is called st.session state. Now this is a variable. This is an object. This is a Streamlit object that behaves like a dictionary. So since it behaves like a dictionary, I can say if my key called count is not in, let's say is not in st session state, so I will initialize this. I will thus initialize this st.session state dot count is equal to 0. So the idea here is now this count, now this count, sorry, this st session underscore state count, this is a variable, this is a key whose initial value is only 0 if it's not initialized. If it's not initialized, if it's initialized, it has some value, it won't be reinitialized again, right? Now let's run this button, the same thing. Let me copy this, and this time uncomment this. If so, instead of count, what I'll just do is I'll just write st dot session state count +1, right? Okay, and always I'm going to click on always rerun. Now can you see the count is increasing? Why count is increasing? Because now count is coming from the key of session state dictionary, or an object is coming from there, and it's not reinitializing. It's not really reinitializing even if I'm clicking on this button. Whenever I click on this button, so though my entire script is rerunning, from top to bottom, but because this session state is like a safe, just like we saw here, session state is like a safe. It has put that count. It has put that count inside its state. These are different keys, and it is going to pull from that safe on all reruns, right? So this is the reason why when I keep on clicking on this count, my count is increasing, as you can see on my screen, right? Perfect. Okay, so yeah, button increasing the count, display the count. We have done this. Let's remove all this. We have already done this. Now since it's a dictionary, it's not a dictionary, it's an object, but it behaves like a dictionary. It's very similar to like a dictionary. So there are two ways you can access the keys in a dictionary, which is like a dot notation, and the other is a bracket notation. Let's see this. So for example, let's define st dot session state dot sum where is equal to 5, right? Very simple. Now what I want to do here is I want to display this st dot write. I can say st dot session state. Either I can write like where, right? Let me say subheader, so that is very clear. Or I can write subheader dot notation, which you have already seen. Nothing fancy, but I just want you to be very clear on this. Where bracket notation is again 5, dot notation is again 5. Very simple, but you know there are two ways through which you can access keys, because it behaves like a dictionary. Session dot state behaves like a session underscore state behaves like a dictionary. So you can use bracket notation and you can use dot notation, right? Now some common dictionary methods which are very, very important, like get, you can use them. So you can also use bracket notation we have done. So we can use get method st dot write. This time I'm going to use get st dot session state dot get, and inside get what I can do here is I can just put in double brackets. What is my key value is where. Get method, same thing. Now the question here is why I would use get. Why will I use get? So the thing here is, if you are trying to access a variable, if you're trying to call a variable which doesn't exist, for example, let's say instead of where, if I write where 5 doesn't exist, right? I haven't defined where 5. If I try to write where 5, it will give me none. But if I I don't use this dot get, if I try to let's say do a bracket or dot notation just like this, where 5, it will give me an error, right? Did you forget to initialize it? Yes, that is the power of get. So with get, with get, what it will do is, if the variable is not initialized, it will initialize this value, it will return a default value of none. So you can use get here. Okay. And then let's also discuss one more thing, clear. Yes. So let's say if st dot, let's say create a button, clear everything. Okay. st dot session state dot clear. This will clear all the session state variables. And then there are other methods like clear, get items. It will give you all the items, it will give you all the keys, whatever keys you have. st dot write, let's say get everything. Dot keys. So let me first clear everything and let me run this. So when I click get everything, it will give me the 0 and where. Just it took some time. So this is the key 0, and this is the key. So this will give me an array. So this is a key where it take like 1 second. So for example, let's say if I create another this thing, if I let me add st dot session state underscore let's say greeting is equal to hello. Remove this line. So I've added this key. Now if I press get everything, it will give me in a list with, it will give me a this a list which is 0 list, and it give me a dictionary. The key will give me a dictionary. The 0 is a variable and the first is a greeting, right? So with keys you can get all the different keys available. Similarly, if you click on items, so it give me all the items. Simple. So it give me all the items if you want that. Anyways, let's clear all this and let's move ahead. Let's continue. So we have seen how to clear all the keys at once. Now let's also if you want to clear one by one, you can use, because it acts like a dictionary, so you can use something like a for loop, for key in list. Session state dot keys. It will get you all the keys, and then what you can do is you can keep on deleting. You can use del, just like a dictionary, st dot session state, and you can pass key here, right? So it will delete you one by one. Simple. If you want, you can run it by yourself. You can define various values. For example, name is equal to Ankit. Let's say profession is teacher. Okay. First, let me write down st dot write key. Okay. And what I'll do is I'll also put inside a button, st dot button. If st dot button clear keys one by one. Okay, name, profession. And so these were the two keys, and it deleted both keys, name and profession, right? Okay, clear? So we have finished our practice 01. Let's go back to our slides. Yes, slides is there. So now let's talk about multi-page apps. So the real power of this session state is when you're talking about multi-pages. That is the real power. And so multi-pages, how do you create multi-page app in Streamlit? though it's a bigger discussion, but there are two ways to create multi-page apps in Streamlit. So one is you use something called st.navigation. You have there your method, their configuration. You use that configuration. But a more simpler way is something called convention over configuration. This is a concept which is widely used in industry when you start building some big projects. Then this convention over configuration is a very interesting method. So here, so configuration, I have told you, you create a configuration file or you use their configuration. So the thing is st.navigation, and you can pass different pages in st.navigation, but that is a very old and a boring way. Here, they have very simple structure. You create each .py file as a new page, right? And then you can just put their order like 0, 1, underscore, whatever, like let's say about us. So first you create a folder called pages, right? In pages folder, you can say 0, 1, underscore about .py, 0, 2, underscore contact.py. Just to give you an example, analogy with website. So here what is happening here is, it's a convention why is a convention? Because the way we write, we are creating our folders. We are creating a folder called pages. Then we are creating inside pages, we are creating the file name 0, 1, underscore, 0, 2, underscore. And now Streamlit is very smart that it will pick those pages. And we have discussed this in detail in the ebook. In the book you will get, we have discussed session state dictionary, common dictionary methods, initializing, managing keys. We have discussed session state. For example, look at this multi-page app structure. So in multi-page app structure, you create my app, which we are here. For example, chapter 4 is like my app, then app.py and pages, page 1, page 2. And now once you do this, let's build this. Let's go back to our folder, command B. Okay. In starter, we'll create a folder, new folder, pages. And in pages, we'll create a file 0, 1 about us.py, right? And we'll create a file 0, 2 underscore contact us.py. Let me create two different files. Here we have created page 1, page 2, right? This is a convention. So why I said 1 underscore 0, 1 underscore, so ordering. So that Streamlit knows which file page it has to place upper, right? Okay. So let's do this. So first we'll create our main app. So this is our main app. Let's say the main app in starter, will create a main app, new file, app.py. Okay. Import Streamlit as st. Perfect. And then let me copy this to save time. I could have written the code. Okay, st.title. If username not in session state, then session state username is blank. If session state username is equal to text input, enter your name. Perfect. Value is equal to this, and then st, right? Navigate to page 1, page 2 to see your name. What is the issue here? Value is equal to perfect. Let's run this. Okay, as you can see, I have not even these files are empty. Like these pages file about us, contacts are, they are empty file, right? Close others. These are empty files, but still it was able to pick up all these files, though it was it also picking the app, about us, and contact us. And the most interesting thing here is it's not picking at 0, 1 underscore, 0, 2 underscore. And if I have to rename them, let me just rename them to, let's say, about, and I'll use underscore about us. So magically what will happen is this underscore will be replaced by space. Look at this. But I have to refresh the page app. Can you see about us? Similarly, contact us. So that is like how when I say convention over configuration, so what we have followed a convention that we'll create a folder, pages folder, and put all these files, and the navigation is automatically built. Now what we can do is enter your name. So what I want to show you here is, if I enter your name, then navigate to page 1 or page 2, navigate to any pages to see your name. How can we do this? Very simple. Let's go back to our book to save time. Let me again copy this. If st dot title, okay. This is title is about us. If username is st session state and st session state, then we'll say st success, else we'll say st warning. All done. Nothing fancy. What we have done is, if username, let me see if it was username. Yes. If username not in session state, then what we'll do is we'll pick from text input and put in our username, and we'll also make our username empty. So now what we'll do is we'll just say hello, whatever your username is, your name was set on the home page, otherwise warning. So let's click this. Please enter your name on the home page. So it didn't got stored. st not in session state, value is equal to state username. Classical error. So there's a classical error. Let me refresh this. When I click on enter your name, what will happen is it will come inside this. It will start this text input. But the problem here is, since I have initialized this inside this thing, so it will refresh this again and again. I have to take this out. I have to take this input box out. And similarly st-write also out. And maybe I can right. Hello Ankit. Got it? Because I was a simple error, simple indentation error if you ask me. This st name initialize, this text input which was giving me the name in my key was put inside the if statement, and because of this, so this is an error. I also have to correct this error in the book. Because of this error, can you see this? Every single time I click on press, it will refresh the page and it will again reinitialize my name to blank. Oh, sorry, it will not reinitialize my name to blank, but it will disappear because this input box will not appear because this was inside the if. Because this was inside the if, what is happening here is, as soon as I type one name, that name goes in session state, the name the variable is initialized, and this will stop working. So I have to take it out. A small indentation error. That is why we should not copy and paste. We should write our own code. Anyways. So this is like a multi-page app, very simple example. Now I can do the same on contact us also. If I just copy paste this time into contact us. This is my contact us page. If username, I'll just put it from here. You got my point. So I'm defining my name here. Let's say some name. I click here. So my session variables are being preserved across pages. That is what? How do you this session state variables work across pages? Simple. Okay. You got the mistake. The mistake I was making was the mistake I was doing was on app.py. I was mixing the initialization and the value in a single if, which we should not. Okay, perfect. Let's move ahead. Now, one more thing I want to discuss is session scope. So the thing here is, so what is the scope in this session state? We have seen session keys persist across different pages. We have seen that. But how much persistent data is between different other scopes, that is we need to understand. So what is the scope of this session state? Where does it live? You need to understand this st.session_state does not live inside your Python file. No, it does not. It lives in the user session, the user who is using your app. Think of it like a backpack that belongs to the user, not the code. So all these values belongs to the user, because user is filling these values. When somebody here is writing their name, I am writing my name Ankit. So this value belong to me. If some other user comes and they write their name, that value will belong to that user. Can you see the screen? So here where I am writing my name, this value belongs to me, right? You have to understand it is global. It doesn't matter if you are in home.py or your app.py or about us, your contact us, it doesn't matter. You don't need to import it. That is what Streamlit is doing. You don't need to pass it as an argument. You don't need. It is just there, accessible from anywhere, and it survives navigation. This is a big one. When your user is going from app to about us or contact us, user is able to see his name again and again. Normally variables would die. If it was in Python variable, the Python variables would die. You know that, right? But the session state survives. It travels with the user across pages. It survives interactions. That's the whole point. Every slider move, every input box, that doesn't matter. This is why we call it session state. As long as the user is connected, their session is connected, it will be there. That's the reason it's called session state. If I refresh my app, let's say if I refresh my app, now it's a new session. It's the user's new session. This time, the name is gone. If I open in a new tab, again, the value will gone, because again the session is gone. The new session is created. If I rerun, let's say if I rerun my app, what will happen? The value is gone because it's a new session. I hope everyone is able to understand that. So the session state is available, the session is there. If session dies, all the values dies. But if session doesn't die, if a user is browsing different pages, it won't die. That's the beauty of it. Let's see. Let's also try opening in a new tab. If we open a new tab will have a different session. It doesn't work like a cookie. It's a new session. Okay, awesome. Let's go back to this. So now we have done all our code, but let's see if there's anything left. Okay, yes, there's one very important thing that is left. Let's go back to our book. So we have discussed multi-page app. I need to, actually there was no error here. Error was when I copied. If you look this st state username is not intended, indentation is not inside if. I copied it wrong. This is right. I copied it wrong. Anyways. So let's do this. We have done this. Widget keys, auto-create session state. Now this is important. So the thing is, whenever you are creating an input box, let's create an input box. Let's open practice 02. Where is my practice 02? Okay. Let me close all these and let me open practice 02. Let me also close this. Okay, let me delete pages folder. Otherwise, it will always keep on showing me here in my navigation. So as soon as I delete that folder, all the pages are gone. So this is my pages 2. So first thing is widget keys. That is very important. Widget keys. So for example, let's say I am saying name is equal to st.text underscore input, enter name, enter your name. So what is happening here is, now this name is just a local variable. Name is just a local variable. But if I want this local variable should become a session variable, what I need to do is, I'll use the same thing, but this time I'll just add another argument key, and I can say key is equal to your username. st.write your username is st dot session state dot get. I have said username. Why I have used get? Maybe it's not initialized, so I don't want to take the risk. Let me run this. Enter your name, Ankit. Your username is Ankit, right? So as soon as I use this key, it will automatically get initialized in my session state variables. So this is how your widget keys auto create session state. And if you don't use parameters, then you have to, if you say I don't want to use parameter, then you can use this also, right? But okay, who wants to do that? Why I want to do so much work? What I want here is, I just want this to get stored in my session state. I don't need to define even a local variable. Simple. Just remember, in your text input, use this key argument. Okay. Perfect. Now let's talk about callbacks. Where's the book? Let's talk about callbacks. With key parameter you have understood. Okay. Perfect. And similarly, you can do in your different widgets, like your number widget, your select box. You can do anywhere, wherever you want. You can do it here. Right? For example, let's say name is Ankit, age is like say whatever, city is Chicago. So these are the keys why I want items. Okay, age 10, Ankit, city Chicago. You got the point? So simple. So with all your input widgets, just use your key. Perfect. Now let's talk about callbacks. This is an interesting thing. Where is in our book? Callback. Okay. So what is a callback? Callback is a function that runs before the script return. Okay. So the problem without callback is, if you look at this code, what we are doing is we are just writing a count variable we are taking from state.count. And whenever we click on a button to add this, let's write this. Let me look at my VS code here. Okay. So what problem without callback? Let's say st dot session state dot count is equal to 0. Let's initialize it, and then we want to write is st dot write sorry, if count not in st dot session state let's first initialize it. Okay, if count is not in session state st dot session state, what I'm doing, if count not in session state, okay, then we'll initialize with the value 0. And if we, and let's write this session state dot count. We'll use dot notation. Now what in the book, what we have done is, let's create a button if st dot add, if st dot button add +1, and we'll just add this +1 to this. So what will happen here? So if you look closely, when I click on the first time, it didn't update it, but when I click on the second time, it's updating. So there is a delay. You can always say I could have written it down, but the better way here is, if I call this function, if I use this function called add_1. Let me define a function. Let me define a callback function. Define add1. And in this function, it's a simple function. I'll do a simple function where I just do this plus equal to 1. And this time, if somebody clicks on a button, then I just call this function. Let me just on click add 1, and then I'll just write st.write. Okay, so what I have done is I have created a callback function add_1, right? Very simple function, and I am just clicking on this function on click, and this will call my callback function. You can use on click, and there is one more function on. We'll discuss about that. And you can call this function. Let's see how it runs. Count. Now it doesn't have any attribute because okay. Right? By mistake, I just kind of commented out. So now what is happening here is, this is calling this function. As soon as I click on this, I can call this function. And it can have multiple use. You know, it can have multiple use. You can call these callback functions to pass this variable, and you can use session variables. Callback functions are not related to only session state. They have immense power, and you have seen this in Python also. You are using callback functions so much. So don't restrict these callback functions to Python. But one of the common uses to update your session variables is through callback functions. That's the reason we have included here, right? Let's move ahead quickly. This chapter is getting long. Basic callback function we have discussed, button, right? And you can add these callback function anywhere. You can add this callback function anywhere in any input widgets. Any input widgets, callback function is there. Now you can also pass variables. For example, let's say, let me create a save label function. Where is my code? One second. Let me initialize a message. Let's say if message is not in session state, then I'll say messages in empty list. Very simple example. Now this time what I'll do is I'll create a callback function that will take some parameters, for example, a text and priority. And as soon as I get any arguments in this method, in this function, I will add it to my list. Okay, simple. Now let's do one thing. Let's create two columns, call1, comma call2, which is equal to st dot columns, and with call1, what we'll do is st dot button. We'll create a button, add normal, on click message, and this time what we'll do is we'll pass these arguments. Can you see this? These arguments, I'm just giving the name of my callback function on click, and I'm passing argument normal, message, and low. And with call2, what I'll do is I'll create another button. This time it's an urgent button. Argument is urgent, message, and high. Okay. Now, if I have to display all the messages, I can write a simple for loop for message in st session. If message priority is equal to high, then error message, otherwise info message. Simple. Let's run this. At normal, normal message, at urgent. I can keep on adding my messages here one by one. What is happening here is I am passing these arguments in this parameter, and I'm passing this as a tuple, right? And they will be passed to my arguments. Perfect. Okay. So with this, I think we have finished our watch mode where we have done code also. Now it's time for the build mode, the final build mode where we are going to build our project. This is where things are going to get super interesting. I want you to look at my screen once more. So I'm going to create a starter project. I will go to project, and in my starter, I'll start creating app.py. Import Streamlit as st. So first, before going into this, I want to show you what is the project we are going to build. So the project we will be building here is, our task is to, yes, first look at the project. So project is very simple. We are going to build a pro tasker app, right? So pro tasker app is a where you can add your task, high priority, low priority task. You will have your task dashboard, and you can even add or delete your task. You can see your active task. You can see your completed task. That is all okay. But one thing what I have seen here is whenever you have to do a project, even if you are doing a small project, so never start writing one giant file. You always start thinking in terms of, let's look at the screen. Let's always think in terms of modularizing your code. If you write in one single file, that is monolith, and monolith are fragile. And intentional programmer like you, they respect structure. This is a structure. Right now we are using a 3-file structure. You can make it like maybe this UI could be a folder. In UI, a folder there could be like header.py, py, the footer, and so on. But right now, to keep things simple, we are using 3 files. Logic.py is the brain. It handles the data. UI.py is the painter. It handles the visual. App.py is your orchestrator. It connects everything together. Separation of concern, all the concerns. The orchestrator is not concerned with UI.py. It will ask UI, come and do your job. It will ask logic.py to come and do your job. The orchestrator is not concerned about their what they are doing or not doing, right? And it also keeps our mind clear, because we are not just writing scripts, we are architecting them, and this is how you do this. Okay, so let's come back to the screen. So this is what we are going to build. Let's quickly start building this. So first I'm going to close my VS Code, close my terminal. Let me click on clear. We'll bring it again. So in app.py, so for this app.py is our orchestrator, right? So this app, first of all, what we already know, what you guys already know, you know what is the session state, you know how to initialize a state, you know that, how to rewrite a state, you know that, you also know how these callbacks with on-click work perfect, and you know how these widgets work. So we are going to use all of them. So first let's create these project files. We already have app.py. Now what we'll create is, we'll create our UI.py. UI.py. And the third file we are going to create are logic.py. Perfect. Now let's quickly initialize our app in app.py. So we'll use st.set underscore page config, and we use page underscore title is equal to pro tasker. That is the name. Pro tasker. And then the layout. So there are a couple of options in layout. So one option is centered. Centered, don't get confused that everything will be centered. Centered means a boxy layout. Wide means it will liquid layout, and there is a none. So the default is centered, but let's use center so that we know that centered means a boxy layout. It won't take all the space, right? As simple as let's run this. So nothing is happening except close other tabs. Can you see the name pro tasker? We have written that name. Perfect. So this is baby step. Now let's build the UI skeleton. For UI skeleton, let me also add small so that I know which file I am working on. In my UI app, this is hash UI, right? Again, what I'll do is I'll create 3 functions. Define render. I am calling them render function, render header. Define render input. Okay. So what I have done is I have done nothing. So I've created 3 different functions: render header, render input, render task. So set these 3 different functions, when I'll call them from app.py, so they will render headers. So let's write something here, like for example, instead of pass, we can say header placeholder. Similarly, what I can do is copy paste to save time, input placeholder and the task placeholder. Perfect. So nothing fancy. I've just added some dummy content. Now I need to wire them. I need to wire them with my these functions. So for this, I'm going to use import from UI, import render header, render input, render task. And now I'll just add the and I'll call them render. First I'll call render header, then I'll call render input and render task. Always rerun. Okay, header placeholder, input placeholder, task placeholder. Structure is coming up. Now we'll keep on moving forward. So now let's go to our UI.py. Sorry, logic.py. Now we need to create our brain. So import Streamlit as st. So for this, what we'll do is we'll create 3 keys in our session state. One is your task. Task will be a list. It will be a list of all the tasks that will hold all our tasks. Then we'll create a temporary space for the new task and a temporary space for new task priority. Let's do that. Because task will store all our permanent tasks, but new task input and new task priority, there will be 2 keys. I'll just write it down. They will hold your form data. Whenever user is submitting a form, it will hold that data temporarily. So whenever user adds a task, we will copy data from temporary space to our main space. I'll show you. So first, let's define a function init state. Let's say pass. And again, if I have to import this in my app.py, from logic import. Why is not coming here? Init state. And what I can do is I can just call this function init state. But this function is empty. Let's build this function. So what we need to do here is we have to initialize. We have to initialize this function. We have to initialize session state with empty task list and form defaults. Let's do that. So first, if task is not in your st.session state, will initialize it with an empty list, right? Then what in the next step will initialize input form state. Initialize input form keys to prevent errors on first enter. We need to do that. Otherwise, what will happen here is, whenever we are going to create an input box and we are going to map the value of that input box with a key argument, we have done it. If we have not initialized it, and if we start passing arguments, it will give us an error. So we need to initialize our new task input and new task input and new task priority as an empty, right? So this won't give us any error, or we can even say, let's say default state. Our default state could be high. What we can say, instead of empty, we can say default state is high. Why? Because we'll only give him 3 options: high, low, and low and medium. We'll never give him anything less than empty. So let's say default priority is high. Again, this is a convention. You can do whatever you want. Perfect. So now this is wire to app.py. If we run this, nothing will happen. Why nothing will happen? Because nothing has changed in terms of UI. We are just initializing our this thing. So now let's start building the header. Let's go back to UI.py. Let's start building the header. So for this, I'm going to close my input and render task so that I can completely focus on my render underscore header. So first, what I'll do is I'll just render the header. Instead of this placeholder, I'm going to remove this placeholder. I'll say title is pro tasker, caption is manage your sprint with priority tracking. Now thing will change. Let me remove it, put it here, right? Pro tasker, manage your sprint with priority tracking. Let's also put a divider so that we know where it's ending, right? So my header is now shaping up. Can you see my header is being now shaping up? Perfect. Let's build a static mockup. It will become dynamic later. Maybe in static mockup we can do progress part. And progress, let's say 0.5. 0.5 means 50%, right? And let's put a caption. Progress 50% completed. Nice. And if I put it like 0.8, 0.8, if I put it like 1.0, 1.0. A small advice, look at 1.0. If I change it to 1, what will happen? What will happen? It will be 100%? No, it will be 1%. It will be 1%. So because if you are using decimal, you have to use 1.0, right? Did I saved it? Yes. Now let me take it back to 0.5. You can use 50 also. 50 will say 50%. So use one convention. If you are using decimal or not decimal, you decide. Perfect. Okay. So our header is now coming up nicely. Perfect. Now let's talk about input placeholders. So we'll close this header. Now we'll focus on input. So for input, what we'll do is I'll create 3 columns. First, I'll create a container where border is equal to true. Then I'll create 3 columns. First, I create a border. Let me also put a divider so that we know. So here is a divider. So this is our task. So here I have 3 columns, 3, 1, 1. So this means the total space is 5, 3 plus 1, 5, and out of this 3 out of fraction 5, because if it is given to column 1, then column 2, column 3. Why I have done this? Because in my first column, I will put the task name with C1. What I'll do is I'll put the task name. Your input goes here. With my C2, I'll put the priority. I'll change it. I'll change it to input boxes. Right now, I'm just making a kind of mock-up, and with C3 will come with a button. I'll change them very quickly, but right now I just want to show you our dummy mock-up. So we exactly know what we are building, right? So input goes here, priority goes here, button goes here. And you can see why it was given 3, 1 and 1. Perfect. Layout input area is coming nicely. Now let's build a task board. So let's close this. Now let's focus on render task one by one. So this is your board. This is our board. Okay. Now in our board, what I want to do here is I want to show active task and completed task. And I want to show using tabs. So let's do that. So tab active, tab completed. I'll go from tabs in a list. I'll say active tabs with a nice emoji. Let's run it. Active task, completed task, right? And let's have some default data. With tab active, st.info, no active task, and with tab completed, no completed task. Nice. Active task, no active task, completed, no completed task. So this is like a static mockup, but at least we have a structure now. We have a proper structure now. Can you see this? So all these are coming from these 3 different functions. Render header. This is my header. This is my header pro tasker. With this my progress bar. Then this my input, render input. Then this is my render board, task board, which is render task. Very nice, very clear. Okay. Now let's add to the next step where we are going to actually add form widgets. But one thing is here, this form widget is thin, is single line. I don't want it to double line. And normally in Streamlit forms, so Streamlit form inputs have like two things. They have label of that input form and widget. Label normally sits above input. I don't want to see label. For example, let me show you example. Let me open this input box, and I'm going to say st.text underscore input. First is task title. Then we can say placeholder is equal to go to gym, learn Streamlit, session state, since you're doing that, right? Learn Streamlit session state, placeholder. And what we can do is we can put it key here, which we have already learned. Key is equal to new task input, right? Remember logic.py, new task input. So this is where we are mapping it. We have forgotten a comma, text input, keys for text input. Yes, I have forgotten a comma here. Thank you for reminding. So now thing here is this task title is coming as a label. I don't want that label. So what I can do is there's another argument here is called label visibility. Label visibility is equal to collapsed. So what, as soon as that label is gone, but is available as an accessibility. It's a good practice, good HTML practices, but the label is gone. Perfect. So learn Streamlit session state. I can add whatever I want. It will be stored in my session state. Okay. Similarly, we'll do it for our priority. Priority will do. With priority, I'll do a simple select box. High, medium, low. Nice. Let me close this also. And with my button, I'll just use a simple button. Add task type is equal to primary. Primary means blue button. Use container width is equal to true. So it will use the entire width. Add task. Perfect. So my user engagement is all done. So whenever somebody types here, go to gym, priority is let's say medium. It's adding to our session state. Right now it's not visible, but it's being added to session state. Everything coming out nicely? If you agree, just add some comment that you have arrived till here. Now after this, everything is so simple. Everything is very simple after this. We have done the most difficult part. We have built the UI. We have got a extreme clarity what we need to do. We can see where all these functions are going where, and how these things are talking to each other. Your orchestrator app.py is getting all this. It's making all them play. It's making init using init state. It's getting the session state variable defined. Render header input. If I just kind of commented this out, your board is gone. So orchestrator is orchestrating every single thing. Perfect. Now the thing here is, I have added task here. Now I have added task here. I want to see some task here. So now the task will come here. They will come as rows, right? One task is one row, second task is second row, third task is third row. It will come as rows. So for this, I want to do some reusable component. Remember dry. Don't repeat yourself principle, dry principle. We don't want to write for every single task. We want to repeat something. So I want some kind of a function which I can call in a loop. I want a component that I can call, and I can call that component in a loop. So let's create that component in our UI.py. So we'll add a new function. The function name is, first let me quickly close everything. Okay, so let's create a new function, render task row. So it will render a single task as a horizontal row. That is his work, his job. And what I'll do is, I'll use a layout like this. A layout like this, which will have a checkbox. If I have completed that task, I'll say check, then title, task, priority, and delete. That will be a layout, a single row which will have these 4 columns. I need 4 columns. So for this, I need 4 columns. But first, let me build a container. Again, I need a container with border is equal to true. With border is equal to true. And I'll create 4 columns. Call check, call title. 0.5 why? It's not exist. 0.5, 0.3. Let me do 1. Let's see, run this. Indentation error. Classical error. Indentation error. Okay, anyways. What is the issue now? Let me take it out. With st container body is true, render task. Okay, it will not come because I have not called this function anywhere. I'm just writing this function first. Let's build this function, then we'll call it. But there is no error. There is no error. We can bring this layout back inside. So the layout says, in fact, let me again do it 0.5. Why 0.5? Because I want my column check to be very small column, and my column delete should be a very small column. My column priority should be bigger, and my column title should be the biggest. Okay, so I have already done this with call check to save us time. So with call check st.write, again hard coded. This is all hard coded. This will come. Will render this properly, but right now this is all hard coded. So the structure is defined but not wired yet, right? We'll wire this. Now what we want to do is, we have let's wire this. Let's not do this hard coded. So first is call check. For call check, what I need is simple checkbox. The value is equal to task equal to done. Key is equal to check underscore task ID. Will pass test task ID. Will show how to pass task ID. In fact, we can pass task here. We have already passed task here. I just kind of forgotten. So whenever we have passed task here, task is a list. So done. Task is done and task ID. These two values will be passed. In fact, task is a dictionary. Sorry, task is a dictionary. So in task, done and ID will be passed here. The key will be passed here. So whenever I have to render a task row, I'll pass this task inside the task row, and it will be the checkbox will be shown here. Similarly, if I have to write task title, so here what I'll do is I'll say task title and priority, task priority. And finally, column delete will have a button, simple button. Button key is equal to delete will delete task ID, right? So this is again a session state variable. Now some of you who are thinking what is task, if you go back into our logic.py, so task is task is a list. In that list we'll have different tasks built with proper dictionaries, right? Okay, so we have 4 functions now: render, header, render input, render task row. But we have not called render task row. But whenever we have to render a task, we have to pass a task dictionary. Then only the task row will be rendered. No data is connected. First we have to add our logic. We have to create a task function. If we have not created a task function, so we can't do this. So we'll create a task function called add task. So for this, I'm going to minimize my init state, and I'm going to create a function add task, right? And add task, I'll pass things like title, priority. Okay. If you look at a UI, so there are only 2 things, title and priority. I'll pass these 2 things. And whenever I pass these 2 things, it will adds new task and clears input, so that I'm ready to add my new task. It's very important. We have to clear the input also. So first, if not title strip, this means if somebody has this is a guard. Let's say guard ignore empty task. We don't want any empty task to be added, so we'll say return. If somebody has given an empty task, will do nothing. We'll just return. It will do nothing, right? Otherwise, what we'll do is we'll create a task. How do we create a task? A task is equal to we need 4 things. We need ID. ID will be a string. And how do we create a ID? We'll use something called UUID. We'll put UUID. This is a unique ID we need to import for this. Okay, import UUID. Right? This is a unique ID. Sorry, not colon. UUID dot. So what it will do is it will create a UUID and store in ID, which is nothing but a string. Second, I'll say title, and ID I have to put in double quotes. Title is again title, nothing. Title I'll get from here. Priority. So I'm creating my dictionary. Priority I'll get from, and the final is done. Initially it will be false. So now can you see the dictionary ID, title, priority, and done? And I just quickly want to go back to my UI and see this. All these 4 are being used. Task done, task ID, task title, task priority. The final is key. I'll also explain how this will work. We'll come back to this. But are you able to understand how we are using all this? Now we need to add this to our simply session.state.task.append is a list. Sorry, it's a dictionary. Task is a list. So we can just append our task to it, our task dictionary to this session state. And now next thing we need to do is we need to make this empty. Our this new task input and new task priority to be empty. Why? Why we want this to be empty? So that the user can add the next task. Clear? Very simple. Nothing fancy. But when do we call this add task? Logic is ready, but not wired to UI till now. Logic is ready, but we need to wire to UI. So let's wire this to our add button. So I'm going to minimize this. So we have two functions, init state and add state. Now let's go back to our UI. So for this, we'll connect button to logic. User types in the form value where is this? Sorry. So what is happening is user types in the form value stored in the st.session state new task input and st.session state new task priority. So we'll create those temporary variables. We'll use those temporary variables, and then user click on add task. Now the button reads those values. Now button is going to read these values, these temporary values, and passes them to add task function. And once the function is done, that function will do very interesting thing is, if you remember, it will also make these two variables empty. Okay, let's do this. So for this, what we'll do is we'll do nothing more in our render task in our button, only in our button. Where is our button? Sorry, is the button is in input. So in this input, which is C3, what we'll do is we'll say add task, type is equal to primary. So let me bring in a new line. Add task, type is primary, use container with is true. And now I'll add one more thing. On click, we'll call an callback function add task. But where is add task? Add task is in, where is add task? Can somebody tell me? From logic, import. From logic, add task, right? So I'm calling a callback add task, and what will be the key? Key is equal to new task. No, sorry, there will be no key in fact. There will be no key, but there will be some arguments. When I am calling add task, if you look at logic, when I am calling add task, I have to pass it title and priority. And for title and priority, I'll use this args. Args is equal to my tuple st.session state underscore, sorry, dot new task input. Is this name correct in my logic? New task input, new task priority. Perfect. So new task input, and the other is st.session state new task priority. Okay. So what I have done is I have say on click add task, and two arguments I have to pass: new task input, new task priority, and these are coming from here with C1. Text input is key is new task input, right? And select box is new task priority, and I am passing these from here because as soon as somebody writes something here, let's say do some work, and somebody writes here medium. So these two variables go and get stored in session state. And when I click on add task, so add task is fetching them from session state. Though they are neighbors, they're neighbors, but like neighbors in metro, they don't talk to each other properly. They are talking them through a session state. Are you getting my point? As soon as you write here, it goes to session state, session state dictionary. You select anything, it will go to session state dictionary, and if add task needs them, it will again call session state dictionary, not to its neighbor, right? Perfect. So now tasks are stored in memory, that's for sure, but they are not visible yet. Where is my mouse? I'm adding tasks, no error. They are being stored in memory, and they are not also getting cleared because I am not wired my logic yet. So let's display some active task. So for this, what we'll do is we'll go to first. I'll close this so that I have some space. So I have this function. Now I have go to render task, my subheader, etc. So in this with tab active, I'm going to say active task. First, I'll let me put this if not active task. If not active task, then it only show st info, right? If not active task. And what is active task? Active task is equal to in session state task if task is not done. So if session state task is a simple list comprehension. If active task, there is no active task, what it will do this. If done is not there, then that they will go in active task. If active task is empty, we'll say no active task, right? Else what we can do is else for task in active task, for task in active task, render task row. This is where things are going to get super interesting. Why? Because now I am calling this render task row here in a loop for every active task. Don't get confused by this. It's a very simple. I know all of you know that this is a if loop. This is a if statement. If t is nothing but task. Whenever we run this for this foreign loop is run, so every task will get stored in t. For every t, it will check if check for a filter. If is done is true, then it will get in active task. If done is not true, it will not get in active task, right? Okay, because if done is like not if done is empty, it will go in completed task. Perfect. Now let's run it. So do some work, do some work, do some work 2, do some work 3, 23. Can you see this? And as soon as I click them, they are not going away, but they will go away. We'll do all this. But at least my UI is coming up, right? My UI is, you are able to see the UI. What we have done is we have just added these active tasks here. Before this, it was only showing me info. Now, info is only shown if there is no active task. If I click on refresh, so there is no active task. Now info is shown. As soon as I add something, buy milk, priority high, it will show priority high as buy milk. So, but in completed, no completed task yet. If I check on this, it should get completed. We have to wire that. Okay. So session is getting longer, but bear with me. We are doing some interesting things. So for this, I'm going to close the render task. Now the thing is we need to toggle task status. So we have to define in logic.py, just like we have done add task, we have to define a toggle status. So whenever you call a task ID, with this done, it should become done. Okay. So for this, what I'm going to call is for task in st dot session state dot task, right? For task in this session task, what I want to do is, okay, if task ID is equal to task underscore ID. I'll explain you why what I'm doing is, then task done is equal to not task done. Flip true and false, right? So what I'm doing here is Whenever I'm going to click on checkbox, I already know the task ID. I'll pass that task ID and I'll just search in all my tasks if that task ID is matching that ID key. If that is done, then if it's done, then I'll make it not done. Otherwise, I'll flip true and false. Right? And once you do that, you have to break. Otherwise, it won't stop because we want to do it only for once. Logic is ready, but this function is not being called. Logic is ready, checkbox not connected. So let's connect the checkbox. Let's connect the checkbox. How do we connect the checkbox? So for this, we have to go to our UI.py. We have to go to this file, render task row, open this render task row. And this time we'll come to this call check. This is where we have to spend our time. Value is equal to task key. Key is equal to, now we have to do on change. On change, we have to call this function on change is equal to toggle status, and key will be passed as key is equal to, sorry, arguments will be passed as task ID. Now where is the toggle status? We have to import it from logic, right? Args is equal to. Okay. So what we have done is we are again calling on change. As soon as on change is called, toggle underscore status should be called and argument should be passed as task ID. As simple as that. Nothing complicated. Rest remains the same. So let's run this. Let's run this. So there's an error. Why is the error? Takes one position argument but 30 argument. Toggle status takes. Okay, toggle status 1, toggle status 1. Let's see with our call check. What we have done here is task ID. 1 second. Value task will done. Key is equal to a check task ID on change toggle status. Let me rerun this. Okay. So it's very small. This thing, this is a double. You have to put a comma here. Nothing. This thing. I just forgot that comma. Perfect. Now let's display the completed task. So for this, we have to go to our tab active. So we have done our tab completed. We have to do a tag completed now. So how do we do it? Again, we'll use the same function done, just like we have done for tab active. We'll copy this function active task. This time we'll do it done task. Same logic, done task, and if t done, not if just remove done. So if not done task, then you have to write st.write no completed task yet, else for task in done task, what the function we call render task row, and will pass task, right? And where is the task is coming? Where the task is coming from here, because we are running that loop. Everything remains same. Let's see. As soon as if I uncheck it, it will come in done task. Okay. Things are coming up nicely. Perfect. So now let's do the delete task. So now I'm going to just copy and paste content because like we have already spent so much time in my logic.py. I'll add a new function, delete task. So for this, again, we'll use the same thing. If session.state task, it will do is it will search for all the tasks with the task ID. And then that will become the, we need to remove the task. That will all tasks, right? Logic is again ready. We have to delete that task. So keep all tasks. So keep all tasks which are not equal to task ID. As simple, the logic very simple. Keep all the tasks except the one matching the task ID. Whatever the task ID is matching, we'll just delete that task and we'll keep all other tasks. Now we have to wire the delete task. So how do we wire the delete task? We just have to go to our delete. First, we have to import this delete task. And then in delete button, this is render task row in our column delete button. What we'll do is st button delete task key is equal to delete task on click. On click is equal to delete task, and we have to pass the arguments is equal to task ID. Yeah. Ha. Again, I forget to put that comma, that pesky comma. So let's see this. Excellent. Let me rerun this. Cannot import delete task from. Did I save this? Yes. Task is deleted. Task is gone. Perfect. So click trash. Task vanishes. Now we need to calculate those metrics. So for this, I need to create a new function in my logic.py. Yes, my file is getting bigger, but we are creating a big project. Get metrics. This time this will calculate total and completed task count. So if task is not in session state, if task not in session state will return 0. Okay, 0, 0. And total, let's say for total is called length of session state task. How many, because it's a list, so we'll just calculate how many are there, and for calculated we'll just calculate completed is sum is an iterable 140 in st session state task if t is done. So all this will be completed. Return total comma completed. We are returning two values. Math is ready, header not using it yet. So what we need to do is, so logic here is 2 out of 4 is done, 50%. 3 out of 4 is done, 75%, right? Very simple logic. So first get metric, we'll just close this. And we'll import this get metrics in our UI.py. We'll just import this get metrics. And in our render header, now this time we have to go to render header, st title pro tasker, total task. We'll just add this total task is equal to complete task equal to get metrics. We'll get these total task, complete task, right? And if total task is greater than if total task is greater than 0, right? Progress is equal to complete task divided total task, and percentage is equal to, let's calculate the percentage also. Percentage is equal to progress into 100. And st.progress is equal to progress. We'll use we don't need this progress now. We'll actually show the real progress. And we'll show the percentage here. Progress percentage is this much complete. Else, we'll say start by, let's also put else also. st.info. We can say start by adding your first task below. That be absolutely clear. Okay, 100% completed. Learn 50% completed. Can you see how session state is coming up and how the project is being completed? Now what we'll do is bulk delete, keep only active. So for this, what we need to do is, let me look at this. Though this is almost done, but let's also, we can also have a bulk delete option. If you want to delete all the tasks. So let's do this. For this, we need to update our render task. In render task, if not done task, we will do else for task. We'll add this button, bulk delete button. Bulk delete button. If we have, I want to add this button here. Clear all completed. And then st.rerun. So I'm just adding a new button. In my completed, clear or completed. Nice. So the project is completed with lots of functionality, But the way we have done is that I want to discuss with you one last time. So we have two files, app is doing nothing but doing orchestration. It doesn't care what other people are doing. It's importing from UI, from logic. In UI.py, we have 4 different functions: render header, render input, render taste, render task row, and then we have logic.py, delete task, different functions. One is initializing a state, one is adding task, one is toggling status, one is deleting task, and one is getting metrics. For getting metrics is, you know this, let's say D something, some task. So this is a matrix, right? Perfect. And get metrics, delete task. So this is a nice project. This is a very good project. This is a very good practicing project. Yes, we have taken so much time, but I hope you have understood the entire thing. And one last thing is, I want you to actually go through common issues, and also I want you to do various exercises for chapter 1. Session state is a very important project. So do it, and I love your feedback. Give me your feedback, what we can do, how we can improve. Was this a long project? Was it a short project? You want shorter project? You want longer project? Tell us and we'll do it. And I'll see you in the next video.